So the second page here, we're still doing the same step. So the first step is always going to be factor. Okay, so we want to always, always, always factor. So from the other page, step 1 is factor, step 2 is restrictions, and then do the simplification. So step 1, step 2, step 3. Simplification is, of course, after. So step 1 is we want to factor. When I look at these two, there's nothing to factor, right? X minus 2 and 2 minus x. There's no common factor. They're not trinomials. But remember how we did the ascending and descending order? This is in descending order of x. This is in ascending order, right? So it's kind of hard to compare them when they're in opposite orders. So you can either, you have two choices. You can factor out a negative and then kind of switch it around. I'm going to switch the order first. And I'm going to do them both in either descending or ascending order. So I'm going to put the x first, and I'm going to do negative x plus 2. Okay, so I want to slow it down a little bit. So I go, okay, I want them both in the same order. So then at least I can compare them the same way. See, look at D. I did the same thing with D. Same thing. I have this one, it has number and then x squared, and this one has x and number. So I kind of want them so I can compare them a bit better. I like to have them in both descending order so then I can compare them. So I'm going to do negative x squared plus 25, and this one x minus 5. And then they're both in descending order. So then I can see, so I just want to show you the difference, right? So same process. I kind of look at this and go, okay, that's better. But here, they're almost the same, but not quite. I can factor out a negative. So if I factor out a negative, like this from the bottom, and make that a positive x, then I get x minus 2, and then the factors are the same. So then I'll factor after. Same thing with this one. I'm just doing them so you can compare them. So whether it's linear, like there's a binomial, or with a quadratic here. So here, same thing. I could factor that, but that negative always throws me off when I try to factor. Some people are okay with factoring first negatives. Kind of throws me off. So I like to visualize it like this. And that helps me see the difference of squares a little bit better. Now, people might have said, but I saw the difference of squares up here. That's fine. So if you factor it in this way, you're going to get 5 minus x, 5 plus x. But again, you're going to be at this stage. So then you're going to have the comparison where they're in different orders again. Right? So if you did 5 minus x, 5 plus x, you're going to have this scenario where they're in other opposite orders. So you have to make sure you can still compare them. So then I fix the order and then factor out the negative, and then I restrict it. So my restrictions, remember, step 1 is to factor, and in this case I had to fix it a little bit, then factor. Then you always want to simplify and cross it off. But before you do that, try to look at your restrictions. If you forget, like I showed you last time, and canceled it, it's okay, but just stop yourself and go, but wait, I was supposed to restrict before I canceled. Okay, so if you accidentally cross it off too fast, that's okay. Still go, wait, even though I crossed it off, I need you to use that as part of the restriction. Okay, so don't drop it off. So here, my restriction, and I'm going to take this denominator. So I usually use like a line or something to have it in a separate. You can do it on the rough paper. And I grab this denominator. Now, does it matter if I grab this denominator here, or this one, or this one? They're going to be the same. So the factored form is usually better, okay? But if you would grab that one, that would be fine as well. It's the same thing. If I go x minus 2 cannot equal 0. Right? X minus 2 cannot equal 0. So I take that. We're going to do my restriction there. And I go, okay, x minus 2, then bring the 2 over. X cannot equal 2. Again, you can do that on the rough paper or on the side. Depends on how big you write. I just need the answer. And some people eventually kind of go, oh, I'm doing it in my head. We're literally using the same concept in my grade 12. We've got the little factors and we're setting them equal to 0. So some people do this step, some people don't. So x cannot equal 2. That's my restriction. So then I'm going to finish the question now and go, okay, now I can cancel. You don't have to show the cancel, right, if you don't want to. Some people are like, ooh, that's just so satisfying crossing them off. They have to be identical binomials, though. They can't be sort of kind of the same. They have to be the same. Okay, so if it's x minus 2, this one can't be x minus 3 or x plus 2. They have to be identical binomials. So this x minus 2 with that x minus 2. Okay, so you take off the same thing. When you cancel them out, remember we looked at this yesterday and I said it's the same thing as canceling out two of the same exact number. So when you cancel them out, they cancel to be 1. Right? So not 0, but it's negative. So the negative's on the bottom. So technically it's 1 over -1 now. But yeah, you can skip that and just go straight to -1. Okay, but this is 1, the top becomes 1, this cancels to be 1, and it's -1 on the bottom, but that just becomes -1 overall. I want you to finish it off, and you can go straight there if you see it. Then I want you to write comma, x cannot equal 2. So I want there to be a comma and then your restriction at the end. Okay, so that's my answer, but I'm saying, but at the beginning, I couldn't use 2. If at the beginning of the question I used 2, it would have made the whole thing impossible, right? And that's just saying where the asymptote was originally. Yep.
This might be kind of like a dumb question, but why is the final answer -1?
Because no matter what you put in this, it's, right, let me just show you. Whatever you put in this, okay, so if I put in 3, so say this is my y equals, so pretend that's a graph. If I put in a table, if I put in 1, 1 goes in here, 1 minus 2 is -1, 2 minus 1 is 1, I get -1. If I put in 3, 3 minus 2 is 1, 2 minus 3 is -1, it's -1. If I put in, no matter what answer I put in, this, when you graph it, it ends up being a horizontal line at -1. So this ends up being a horizontal line. And if you're like, wait, that doesn't make sense, what about the hole? There's a hole at 2. It just can't equal there. So there's an open hole there, and my graph it. When I graph it, look, every single, put 5 minus 2 in, that's 3. 2 minus 3 is -3. 3 divided by -3 is -1. Every answer I get is always -1, but there's a hole here. So we're going to look at that in 2.5, which is that if the factors are the same and you end up canceling it, it ends up being holes in my graph. And then the rest of the graph looks like the rest of it. We're actually going to look at that same thing. Yeah, so it's weird because it's like the whole graph, the whole graph is -1. After you cancel the whole, you graph what's left. So this, when you're canceling it, so that's actually funny because it leads to 2.5. When you cancel it, that's a hole. That's actually, you know how we were graphing the domain and range? And you're like, where are these holes from? These. If you have the same factor on the top and the bottom, this punches holes in your graph. So it's not like the whole graph disappears, but there's a hole at 2. So where's this hole? At x is 2. Right? So it punches holes. So wherever I'm canceling off, that's a hole punched in my graph. And then if it's left on the bottom, we learned that from the other day, it's an asymptote. So we're going to do that in 2.5. So holes are where they're top and bottom, and then asymptotes are where it's only on the bottom. Yeah. Right? So it ends up being a horizontal line with the hole. Very weird, right? So here, this one doesn't end up being a horizontal line because when you factor it, so I get to here, okay, I haven't fully factored it, so I'm going to fully factor it now. So I go negative, it's x minus 5, and x plus 5 all over x minus 5. So now it's fully factored. But my restriction only comes from the bottom. Okay, so it only comes from the bottom there. So my restriction, again, on the side, do you need to calculate that or you're okay? Can you do that in your head yet? Right? If you can do it in your head, you go x minus 5 cannot equal 0. So x cannot equal 5. Right? So not too bad. So yeah, you can do that in the rough and keep that there. And then the canceling part, the simplifying part is this. I fully factored it, so I got that. What are you going to cancel? You're going to cancel this with this one, right? Fully out. Does that make sense? Gone, gone. The exact same binomials. You're not allowed to cancel kind of similar. They have to be the same binomials or monomials or trinomials. We don't usually do trinomials, right? Most we factor is 2, right? So monomials and cancel the exact same. Write down what's left over. So you can write down this. Or I don't care if you bring the negative in. Okay, so it doesn't matter which one. If you said, oh, I distribute it, that's okay. Comma, x cannot equal 5. Right, so my final answer is that I end up having a line, but there's a hole punched at 5. Okay, we explore more of that next year. We do look at it a little bit this year, which is nice, and then next year we do more of this, like, so what happens with this. But this is our first year we get to learn what a hole is. So those open circles that we were showing you in the domain and range, that's where a hole was. Open circle means there's a hole punched in the graph. Right, just at that spot it's missing. Okay, try it again. So same process. Factor. Can we factor the top? No. If I give you something already factored, it's a gift. So just take that gift. Don't unfactor it, please. I already factored it for you. I'm going to write it here. So this, leave it factored. The bottom, let's factor that. All I see on this one is common. Just common, right? 2x. And so it's x plus 4, fully factored. I go over here and I'm going to do my restriction. So take each one of the factors for the restrictions. You're going to take this one here and that one. It's allowed to be a monomial. Remember, because we common factor monomials out all the time. So then we're going to say 2x cannot equal 0. If 2x cannot equal 0, divide both sides by 2. X cannot equal 0. Yeah, 0. Okay. Then take the other factor. So x plus 4 cannot equal 0. So x cannot equal, bring the 4 over, -4. Okay? And if you're getting faster at that, that's fine. And if you're still taking your time, that's okay too. Okay? You want to do enough of these so you're like, oh yeah, the pattern's here. Factor, restrict, and then cancel and finish it. So I got my restrictions. I'm going to save those two for the ending. Cancel, watch. I can cancel these two binomials, perfectly gone. I can also cancel monomials though. So if I had given you this in grade 9, do you remember we used to just cancel monomials? That's all we did. So you would say the 2x's cancel to become the 1, right? So then you would write down what's left over and say 1/2. So that's what we're doing here. So that's gone already. So then you're just canceling here, the 2x's. So the monomials cancel just like what we used to do in grade 9. We used to give you a bunch of monomials with a bunch of letters, right? So you're just doing that. So you're canceling the x's. And then you got 1 left, so it's 1/2. Okay? So this will be 1/2. Comma, x cannot equal 0 or -4. All right, next one, same thing. Let's factor and cancel. So first step, factor. You put it, Lennon, you put it in the bag. Okay, let's factor. All right, so equals, whoosh. What would you factor out of the top? 4. Good. 4. What do you got left? X squared minus 1. If you can see that right away, then you don't have to write it again. So I sometimes do this and I go, oh crap. So I might erase it and then do this. Otherwise I have to write it twice. So it's up to you. You can write it and then you have to look again and fully factor it. Some people write it twice and then they go, okay, I wrote it. So then on the bottom, it's a trinomial, multiplies to 1, adds to -2. So it's x minus 1, like that. Then you'd have to do it again for the top. If you can see that it's a difference of squares right away, you can go straight here. Okay, so sometimes you go, okay, I grabbed it, I factored it on the side and put my answer. That just saves you a little bit of writing. I don't mind if you write it again, it's up to you. But if you want to skip to this, I'm marking that it's fully factored. Okay, so fully factored with the common factor out. So I'm looking for this step, but if you want to do a middle step, you can do this. Okay, factor, fully factored, nothing else I can do. Okay, restrictions then. Restrictions here. Oh, and there's 2 of them. Can I also write it squared? Yeah, you can. So on the bottom, you can write it like this or like that. It's up to you. For a final answer, you want to always clean it up, but I'm not done yet. Like, I'll clean it up later. If this was going to be my final answer, I would clean it up with a squared.
I think I left my notebook in here. It's blue.
Anyone find a blue one?
Fess up. Who has it? I can't. Okay, left the notebook in here and I like need it.
If it shows up, we'll let you know.
Perfect.
Does anyone see it? Yep. Did anyone move anything? No. It's not on the card. Okay. I'm going to pretend that I'm believing her. Okay. So then grab the bottom. Do you need to do this twice? Please don't do it twice, right? So just one time, x equals 1.
Not equal.
Maybe she wanted to, thank you, maybe she wanted to be YouTube famous because now she's on my recording, and now when she'll look back and she'll find this particular recording and then like it and subscribe. Just joking. She doesn't. Okay, but anyway, so not equals, thank you. Does that make sense? So don't do it twice. So when you see two of them, only once. You're only going to say it once. Don't say, don't equal 1, don't equal 1. You're repeating yourself, which is what I like to do. But you don't want to say it twice to me back, okay? So just one time. And yes, you can write it this way or that way. If it's a final answer, you want to clean it up. But here, I'm still a middle answer. Plus, I'm going to cancel it. So my next step is canceling. So I don't care if you cancel it here and say, oh, well, I took away 2 of them and I left 1, or if you cancel it like this, right? So long as you know that there was 2 brackets, you either cancel it here or cancel it like that. Okay, either one is totally fine. Okay, and then let's write down what's left over. So 4, x plus 1, and x minus 1. Let's leave it factored. Okay, unless we have to finish something off, but we're good here. It's nicely factored on the top. You don't have to distribute it in. Don't do more work. Beautiful. Bottom's good. I don't need a bracket on the bottom anymore because there's nothing around it. So I do want you to clean up, right, and just say, oh, I don't need it there, comma, x cannot equal 1. And don't state it twice. Okay, don't state it twice. Any questions there? Good?